All right, so this is the allele frequency crash course for evolution. Don't be nervous if you don't know what allele frequency means yet, because you're going to learn it by the end of the crash course today. So you should have the allele frequency packet in front of you, and I'm going to go ahead and read aloud the beginning paragraph to give you an idea of what we're going to learn about. So, populations of most living organisms exhibit genetic diversity among individuals. Certain traits in a population give some organisms a greater chance of survival than individuals that lack these traits or don't have them. Because these traits tend to increase survival, these individuals produce more offspring that will also have the trait that favors survival. Over time, the number of individuals within the population who have the favorable trait or the good trait increases, while the number of offspring who do not have the trait decreases. So essentially what this is saying is, in a population, there are individuals who are better suited for survival than other ones. So there are some individuals in a population that have a better chance of surviving and living than other ones. So we're going to take a look at an example to have it make a little bit more sense. So on your first page, you have a graph in front of you. It's the color variations in moths in Great Britain. If you don't know what a moth is, it's pretty much like an ugly butterfly. So what we have here is we have two types of moths. We have light moths, which are the dotted line, and dark moths, which are the solid line. We are looking at the years between 1800 and 2000, and what we're measuring is the number of moths that we can capture. So the number of moths that we have that are alive, right? So number 8, we're going to use this graph to answer the following questions. So which moth color was more prevalent before 1850? So all that's saying is what moth color were there more of before 1850? So before 1850, there were more of the dotted line. So there were more light moths before 1850. Way more light moths than dark moths. Dark moths are almost at 0. All right, B. Which color was more prevalent between 1900 and 1950? So we're looking in between these two main years. And we see that the dark moths are way higher than the light moths now. So the dark moths were more prevalent between 1900 and 1950. Number 9, describe the change in the percentage of light-colored moths and dark-colored moths between 1850 and 1900. So what's happening between 1850 and 1900? So let's take a look at our light moths first. Our light moth population is going down or decreasing, and at the same time, our dark moth population is going up or increasing. So between 1850 and 1900, the light moth population decreased and the dark moth population increased. We don't know why yet, but we know that it's happening based on our graph. All right, then for the next one, describe what happened to the light-colored moths and the dark-colored moths between 1950 and 2000. So now we have another change in our graph. Between 1950 and 2000, the light-colored moths are now increasing in population. There's more of them. And the dark-colored moths are now decreasing in population. There's less of them. Go ahead and write all those down. All right, so we have our same graph up here, and now we have two different pictures. So we have pictures of the same tree taken at two different times. So these moths are sitting on this tree. This first tree you can see is way lighter than this darker tree over here. We also have our dark moth sitting on the tree and a light moth sitting on the tree. You can barely see the light moth, but it is definitely there. On this dark tree, we have our dark moth sitting next to our light moth. So what you need to answer is, looking at this first picture, when do we think this was taken? Who would have a better chance of surviving on this light-colored tree? The moth that has the better chance of surviving and not being eaten is the moth that can blend in more. So if we take a look at this, we see that that's our light moth. Our light moth, you can barely see it. So a predator can barely see it. So this first picture must have been taken between 1800 and 1850 because the white moths are better able to blend into the environment, so their population would be higher. If they can blend in, they're not going to get eaten. This other tree, though, must have been taken at a different time because now we have our dark moth that blends in way more than our light moth, right? So our white moth is going to be eaten a lot faster than the dark moth because this guy sticks out. He sticks out. You can see him a lot better. So can predators. So this picture must have been taken between 1900 and 1950 because the dark moths are now better able to survive and blend into the environment. So their population would be higher, just like it is between 1900 and 1950. Okay. So the next page, this is what happened to cause the environment to change. During the Industrial Revolution, through the mid-20th century, factories and power plants which burned coal produced large quantities of soot and smog. Near industrialized areas, black powder covered surfaces, including the moth habitat. So now we have a ton of black powder that's just covering all of our trees. So our first question, which color moth would have a better chance of surviving predation or better camouflage to hide from predators on this dark surface? Our dark moths would have a better chance of surviving because they blend into the dark surface. The better you're able to blend in, the less likely you are to be eaten. How does this help explain the change in the colors of moth population shown in Model 2? Well, if the dark moths were able to blend into the dark surface, their population increased. Since the white moths did not blend in, they were more likely to be eaten by a predator and their population decreased. All right, and our final thing that happened. Clean Air Acts were then passed by governments of industrialized nations beginning in the mid-1950s. Using this information, explain why the moth population shifted again. So Clean Air Acts, that means our pollution is going to go down. So if our pollution goes down in that moth habitat, our trees are going to become lighter. So the Clean Air Acts would have decreased pollution, so the trees would have eventually become light again. With the light trees, the white moth population now would be able to blend in more, and they would increase because they'd have more babies, and the dark population will decrease. All right, so now we're going to give this whole concept a term. So what this is called is allele frequency, and all that is the more favorable traits get passed down because individuals are better able to survive. So if you're better able to survive in your environment, you're going to live long enough to have babies and make more babies that are able to survive. If they are better able to survive, they are more likely to reproduce and pass down the trait to their babies. Individuals who do not have the favorable trait are less likely to live long enough to reproduce and pass the trait down because more than likely they're going to get killed or eaten before they have a chance to have a baby. Why do you think individuals who do not have the favorable trait are less likely to reproduce? They are less likely to reproduce because they die before their reproductive age. They're killed off before they have a chance to pass down their genes. All right, let's practice an EOC question with this. A genetic disorder in an animal population is fatal, all that means is deadly, but does not disappear from the population even after many generations. So even though it's deadly, it's not disappearing. People are still getting it. Which statement is an explanation for the continued existence of this disorder? So how could it still be showing up even though it's deadly? People die if they have it. A, this disorder affects only a small number of individuals. B, the disorder resulted from a random gene mutation. C, the effects of the disorder are insignificant until well after sexual maturity age, so these individuals are able to reproduce. Or D, the fatal symptoms occur only in individuals that have one gene for the disorder. So the only way that this gene could continue to show up in the population is if the effects of the disorder don't happen until after they're able to have a baby. Once they have a baby, then maybe the effects of the disorder happen and they die. But they're able to pass down the trait because they're living to the reproduction age. All right, go ahead, try those other two EOC practice problems in your packet. And when you are done, come see Ms. McGrath for your next assignment.